Two angles are complementary. 3 times the measure of the larger angle is 10 degrees less than 4 times the measure of the smaller angle. Write a system of linear equations and its corresponding matrix equation to represent the system. Solve the system using matrices. Okay, so we need to write our system of equations here. It first tells us that two angles are complementary. And so that immediately tells us that two angles, we could name them x and y, will add up to a complementary angle, which we know is 90 degrees. And so we could write x plus y equals 90. And then it also tells us 3 times the measure of the larger angle is, and then is often a word used for equals, 10 degrees less than 4 times the measure of the smaller angle. And so let's just call the larger angle x and the smaller angle y. And then it says 3 times the measure of the larger angle. So we just say, well, 3 times x, and then is, so that'd be equals 10 degrees less than 4 times the measure of the smaller angle. So 10 degrees less would be 10 subtracted from, and then 4 times measure of the smaller angle, so 4y. And so there's our system, and we need to put that into standard form. The first one is already in standard form because it has the x term, y term, and then equals the number. And we need to make the other equation look that same way. And so we have the 3x in the right spot, and then to get the y in the right spot, we could subtract 4y, and that moves it to the other side. So we'd have 3x minus 4y equals, and then we're left with negative 10, since 4y minus 4y is 0 on that side. And so now that we have our system, we can go ahead and put it into a matrix. So using the coefficients, it would be 1x plus 1y. So we can put 1 and 1 in the top row as the coefficients, and then the second row, 3 and negative 4. And then we'd have our x, y, and then equals 90, negative 10. So to solve this, we need to find the inverse matrix of 1, 3, 1, negative 4, and then we can multiply it on the left of both these matrices, and that will help us solve for x, y. And so let's remind ourselves of the inverse formula. And so in our matrix, we have A, B, C, and D as those numbers there. And so we can go ahead and just fill it in here. So it'd be 1 over 1 times negative 4 minus 1 times 3. And then our matrix, we would just switch the places of A and D. So it'd be negative 4 up here, and then 1. And then we make B and C negatives, or change the sign. So it'd become negative 1 and negative 3. And so then simplifying this out, then we'd have 1. And then on the bottom, 1 times negative 4 is just negative 4. And then negative 1 times 3, that's just minus 3. So negative 4 minus 3 gives us negative 7. And so it'd be 1 over negative 7 and times our matrix. And so multiplying that out, then this is just a scalar. So negative 1/7 times negative 4 is positive 4/7. Negative 1/7 times negative 3 is positive 3/7. Negative 1/7 times negative 1 is positive 1/7. And negative 1/7 times 1 is negative 1/7. And so we can go ahead and put this matrix, our inverse, on the left side of both of our matrices in this equation. Okay, so just for simplicity, I did erase some of our work there so that we could better focus on our equation here. So the inverse matrix times the original matrix will just equal the identity matrix, which is 1, 0, 0, 1. And then on the other side, then we just need to multiply these matrices. So multiplying it out, we take the first one in the first row, so 4/7 times the first entry in the first column, 90, plus the second times the second entry in the first column, negative 10. And then on the bottom, same thing, but we'll use 3/7 times 90, and then plus negative 1/7 times negative 10. Finally then, the identity matrix times xy just gives us xy, and you can verify that by multiplying it out. And then typing this first row into the calculator, then 4/7 times 90 plus 1/7 times negative 10 actually gives us a very simple number, 50. And then 3/7 times 90 plus negative 1/7 times negative 10 gives us 40. And so our final answer is xy equals 50, 40. And that just means that x is 50, which was our larger angle, so the larger angle is 50 degrees, and then y is 40, which means the smaller angle is 40 degrees. So let's go ahead and summarize our answer. Let x represent the measure of the larger angle and y represent the measure of the smaller angle. X plus y equals 90, 3x equals 4y minus 10 becomes x plus y equals 90, 3x minus 4y equals negative 10. 1, 3, 1, negative 4 times xy equals 90, negative 10. Xy equals 50, 40. The measure of the larger angle is 50 degrees, and the measure of the smaller angle is 40 degrees.